Viewers, welcome to another interesting video. Let's take a look at the problem on the board. So here, guys, we have an interesting cubic polynomial here. M squared minus m cubed equals 36. As you can see, this intentionally made like this because it's an entrance examination problem. It's actually an Harvard entrance exam math problem. So we are not going to solve this cubic equation in the manner that we know, because time is of the essence when you are solving or when you are attempting entrance examination problem of Ivy League universities in the United States. So I shall go ahead to factorize this problem completely without rearranging the polynomial. So we shall do that. So here we have m squared minus m cubed minus 36, everything equal to 0. Because of the peculiarity of this problem, I can actually split 36 into two numbers, one a square number and the other a perfect cube, such that it will fit perfectly to this problem. So we are going to write m squared minus m cubed minus 9 minus 27 equal to 36. So you can see that if we add negative 9 and negative 27, we have negative 36. So you can begin to see the pattern unfolding. 9 is a square number. I will factor it with m squared. 27 is a perfect cube. I will factor it with m cube. So we are then going to be having m squared minus 9 minus m cube minus 27 equal to 0. Now, because of this negative sign here, I will factor out negative. So I'll write m squared minus 9 minus m cube plus 27 equal to 0. So now I can write 9 as 3 squared. So I will write m squared minus 3 squared. Here, I can write 27 as 3 cubed. So I will write m cubed plus 3 cubed. Everything equal to 0. So folks, you can see the beauty in this problem. Then, all I need to do is to apply some algebraic identities. We are all used to difference of two squares. A squared minus b squared is equal to a plus b multiply a minus b. Then we also know very well that if we have sum of two cubes, if we have a cube plus b cube, we can actually factorize this. We take a and b in one parenthesis, add it. Then we take a, square it. We take a and b, multiply it and add a negative sign there. Then we take b and we square it. So with these two well-known binomial formulas, we shall refine the context of this problem. So with this formula, I can then write m squared minus 3 as m plus 3, then m minus 3. I'll put a negative sign. Then I can write a cube plus b cube, okay, like this. So then m cube plus 3 cube will take this exact same form. So that's going to be m plus 3 in one parenthesis. Then I will take m and square it. Then take negative, multiply m and 3, that will be 3m. I will take 3 and square it, which is 9. Everything equals 0. Please, guys, you have to manage. The space is quite tight. Then we can then factor out, a common factor. These two guys and these two guys, m plus 3 is common. So we'll factor out that. That will be m plus 3. Then I will open a big bracket. So m plus 3 divides these two parentheses. M minus 3 will be left. Then I have a negative sign there. I will open a parenthesis. M plus 3 divide these two guys here, these two parentheses. M plus 3 will cancel out. So we have m squared minus 3m, then plus 9. I will close the parenthesis, close the bracket, everything equal to 0. So all we just need to do now is to clean the inside of the bracket. So if I use negative to distribute this parenthesis, I'm going to be having m plus 3. I'll open the parenthesis. Then m minus 3. Like I said, minus multiply, plus that will give us minus. Minus multiply minus, that will give us a plus. Minus multiply plus, that will give us a negative, sorry. That's an oversight. That's minus 9. Everything equal to 0. So we go over to the other side of the board. So far so good. We've done very well. Let's try and see if we can collect like terms here. Okay, we have a quadratics here. Think that's m squared. So I can say, okay, this implies that m plus 3, then negative m squared. Then we have m plus 3m. That will give us 4m. Then we have negative 3 added to negative 9. That will give us negative 12. So everything equal to 0. So here we are going to invoke the zero product property. So if we have a multiplied b is equal to 0, it implies that either a is 0 or b is 0 or both a and b are 0. So then we can then say that m plus 3 equal to 0, then minus m squared, which is a quadratic, plus 4m minus 12 equal to 0. So our first solution, when plus 3 crosses, that will give us a negative value. Then, or we are going to solve this quadratic, m squared plus 4m minus 12 equal to 0. Now, we often advise students to actually make sure that a quadratic equation is in a standard form before applying a formula or even factorizing. So I can decide to multiply every term here by negative 1. So that's going to give us m squared minus 4m then plus 12 equal to 0. So we shall solve this quadratics by using the formula method because this cannot be factorized. So the value of m will be negative b plus or minus b squared minus 4ac upon 2a. So guys, this is becoming very interesting. So the value of negative, okay, the value of a is 1, the value of b is negative 4, and the value of c is 12. So I will plug them into this formula because there's a negative sign here already. So we are going to be having positive plus or minus. Now, the square of negative 3, that will give us 16. 4 multiply 1 multiply 12, that will give us 48, all divided by 2. So folks, if we subtract 48 from 16, that's going to give us the square root of negative 32 all over 2. Okay, okay. Okay, we are going to have complex root here, but regardless, we shall continue. Now, for me to write the square root of negative 32 for the sake of our audience in high school, I can actually say this is equal to m equal to 4 plus or minus, I'll say the square root of 32 multiply the square root of negative 1 all over 2. And the square root of 16, I can actually reduce the radical by using 2 and 16. So I can also say that m is equal to 4 plus or minus the square root of 16 multiply the square root of 2 multiply the square root of negative 1 all divided by 2. In advanced mathematics, the square root of negative 1 is actually imaginary, which is iota. And the square root of 16 is 4. The square root of 2 is rad2 or radical 2. So I can write the value of m to be m equal to 4 plus or minus 4 radical 2 iota, all divided by 2. So folks, this is an interesting problem. So we can then bring out the two values of m. So before we do that, 2 is actually common. I can divide out. So if I use 2 to divide, I'm going to be having m equal to 2 plus or minus 2 rad 2 iota. So if I bring out the two values, which are complex roots, I'm going to be having m equal to 2 plus 2 rad 2 iota. Then m equal to 2 minus 2 rad 2 iota. And the first solution, which is actually real, is actually m equal to negative 3. So guys, it's a beautiful problem. We've come to the end of yet another interesting tutorial. Please ensure you give this video a like and make sure you subscribe and turn on the post notification so that you wouldn't miss out in our next video. See you next time, and God bless.